Now, for the properties of unsaturated hydrocarbons, the main ones, okay, alkenes and alkynes, you're gonna have to make sure that you understand what's gonna be the difference between an alkane, an alkene, and alkyne in terms of their physical properties. Which ones are gases in a room temperature, which ones are liquids, and how are the trends changing. So that's what I mean with properties. Also, boiling points are a good way of looking at these properties because if it has a very low boiling point, it means that it's a gas naturally occurring. If it has a higher boiling point, this means that it's getting denser and denser, so it's going to be more and more liquid, 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 oily, oily, oily. And solubility in water, it's always the universal solvent. Since they are made out of only carbon and hydrogen, they are still hydrophobic. They hate water. They don't like to be near water. So just keep that in mind. How is that density changing as you increase the size of the alkyl chain? How is that density changing as you have branches around the double bond, okay? In terms of chemical properties, this is going to be the strongest part of this chapter. The first thing that you need to understand is that these molecules are electron rich. They are going to be more reactive than alkanes because alkanes didn't have any polarization within the molecule. This double bond, it's electron rich. It's telling you that there's electrons, extra electrons, or more electron density in between these two carbon atoms. So that's what you need to understand. And from your chapter 6 reading, I hope that you learn that electron rich molecules are often referred as nucleophiles because they are attracted to nuclei. So these molecules that are electron rich, they are gonna suffer the same type of reaction every time. If they are electron rich, they are going to attack nucleophiles. And in a molecule that is polarized, there's always going to be a partially positive, a partially negative portion of it. So if this is electron rich, it's going to attack the electron deficient part of the other reagent. The final product is always going to be an alkane, an alkane, a tetrahedral carbon atom coming from a trigonal planar carbon atom. So that's important for you to remember from your previous assignments. Every time that you have an electron-rich molecule, it's going to react with the portion of another reagent that is electron deficient, and you're going to have an alkane at the end. Where are these A and B located? That's what is going to be more for you to study. Each of these reactions is in general called an addition reaction. Okay, addition. I'm adding whatever I put in my reactor or in my beaker is going to be incorporated to the final product. So these are all classified as addition reactions. What is going to be the name of each one of them? It's going to change depending on what is being added. If you add halogens, it's going to be called halogenation. If you add hydrogen, it's going to be called hydrogenation. If you add water, it's going to be called hydration. And if you add halo acid, it's going to be called hydrohalogenation. 。 So you see, you don't have to memorize as long as you know what the molecule is made out of. Okay, halogens are represented by the letter X. Halogens can be fluorine, chlorine, bromine, iodine. There's one last uh, addition that we're going to cover. Is going to be the hydrogenation, the halohydration. So you're adding aloe acid and then water. So that's going to give you different final products at the end. What are going to be the final products at the end? For this one, it's going to be the halogens. For this one, it's going to be the hydrogen. For hydration, one of them is going to keep the hydrogen, the other one is going to keep the OH. And for for hydrohalogenation, one of them is going to keep the hydrogen, the other one is going to keep the halogen. These are going to be more uh, challenging in terms of deciding where is the OH going to end or where is the halogen going to end. That's what you need to understand what Markovnikov rule means. Hydrogen, where more hydrogen is, that's Markovnikov's rule, and that's where it's going to guide you to decide where to plug in this hydrogen. Markovnikov's rule, hydrogen, where more hydrogen already is. So if you have a carbon with uh, other carbons here, and you have a carbon with more a carbon with other carbons and a carbon with just hydrogens, the hydrogen is going to add to this one. Markovnikov's rule, very important.